CNNQR, Convolutional Neural Network, Quantile Regression, in Amazon Forecast. What is CNNQR? CNNQR is a deep learning-based forecasting algorithm specifically designed for handling large numbers of related time series. It combines two core components. Convolutional neural networks, CNNs. These are excellent at automatically learning patterns and features from sequential data. In CNNQR, the CNNs process the time series data to extract relevant temporal features. Quantile regression. Instead of predicting a single point forecast, like the average or median, CNNQR predicts a range of possible outcomes by estimating different quantiles of the future distribution. This provides a more complete picture of the forecast uncertainty. For instance, it can predict the 10th, 50th, median, and 90th percentiles of future demand. What makes CNNQR special in Amazon Forecast? Handling related time series. This is the key strength. CNNQR can effectively learn shared patterns and dependencies across many related time series. For example, if you're forecasting sales for multiple products, it can learn how the sales of one product influence the sales of others. Incorporating related data, external features, CNNQR can incorporate additional time series data that might influence the forecasts, such as weather data, promotions, or economic indicators. These are called related time series, or external regressors. Handling item metadata. You can provide additional information about each time series, such as product category, location, or customer demographics. This item metadata allows the model to learn specific patterns for different groups of time series. No future values required for related data. Unlike some traditional time series methods, CNNQR doesn't require you to provide future values for the related time series. It only needs historical data for these features. This is a huge advantage in many real-world forecasting scenarios. How is it different from traditional time series methods? Traditional time series methods like ARIMA or exponential smoothing, ETS, typically model each time series independently. They struggle to capture complex dependencies between multiple time series and don't easily incorporate external data or item metadata. CNNQR, by using deep learning, can automatically learn these complex relationships. Other algorithms that handle multiple time series. Besides CNNQR, Amazon Forecast also offers DeepAR+, another deep learning-based algorithm that uses recurrent neural networks, RNNs, instead of CNNs. It's also well suited for related time series forecasting. Prophet, not in Forecast directly, but can be used with SageMaker. Prophet is designed for time series with strong seasonality and trend, but it's less effective than CNNQR or DeepAR+ for handling many related time series and external data. Open source libraries. Yes, you can implement similar approaches using open source libraries. GluonTS, a Python toolkit for probabilistic time series modeling, built on top of MXNet. It provides implementations of DeepAR and other deep learning-based forecasting models. TensorFlow probability and PyTorch forecasting. You can build custom CNN or RNN-based models with quantile regression loss using these libraries. Why CNNQR in Forecast is often preferred. While you can use open-source libraries, Amazon Forecast handles much of the heavy lifting for you. Data preprocessing and feature engineering. Forecast automates many of these steps. Model selection and hyperparameter tuning. Forecast provides automatic model selection and hyperparameter optimization. Scalability and infrastructure management. Forecast is a fully managed service, so you don't have to worry about managing infrastructure. While the exact CNNQR implementation used within Amazon Forecast is not open-sourced, the underlying components in similar architectures can be implemented using open-source libraries. Here's a breakdown. Components of CNNQR and open-source equivalents. Convolutional neural networks, CNNs. This is a very standard and widely available component. You can easily build CNNs for time series data using TensorFlow, Keras, TF, Keras, layers. Convo1D is used for 1D convolutions on time series data. PyTorch, Torch, NN, Convo1D provides similar functionality. Quantile regression. This is also readily available. Loss functions. You can implement quantile loss functions in TensorFlow, Keras or PyTorch. For example, in TensorFlow, you can define a custom loss function that calculates the quantile loss. Stats models, Python. This library provides tools for statistical modeling, including quantile regression. Building a CNNQR-like model in open source. You could construct a model that has the key characteristics of CNNQR using open source tools. Input layer. Take your time series data and any related time series or metadata as input. CNN layers. Apply 1D convolutional layers to the time series data to extract temporal features. Fully connected layers. Use fully connected layers to process the output of the CNN layers. Output layer. Use an output layer that predicts multiple quantiles. You would have multiple output units, one for each quantile you want to predict, e.g., 0.1, 0.5, 0.9. Quantile loss. Train the model using a quantile loss function. Libraries and frameworks. GluonTS. As mentioned before, GluonTS provides pre-built models that are very similar to CNNQR and DeepAR+, making it a good choice for time series forecasting with deep learning. TensorFlow probability. This library provides tools for building probabilistic models, including quantile regression. PyTorch forecasting. This library is specifically designed for time series forecasting with PyTorch and offers various models and tools. Why Amazon Forecast is still often preferred. Even though you can implement similar models in open source, Amazon Forecast provides several advantages. Simplified development. Forecast handles data preprocessing, feature engineering, model selection, hyperparameter tuning, and infrastructure management, which can be time-consuming to implement yourself. Scalability and reliability. Forecast is a fully managed service that can scale to handle large datasets and complex forecasting tasks. Integration with other AWS services. Forecast integrates seamlessly with other AWS services like S3, CloudWatch, and Lambda. In summary, you can implement CNNQR-like models using open-source libraries like TensorFlow, PyTorch, and GluonTS. However, Amazon Forecast provides a more convenient and scalable solution by handling many of the complexities involved in building and deploying these models. If you need fine-grained control or have specific research requirements, using open-source libraries might be more appropriate. But for many practical applications, Amazon Forecast offers a compelling alternative.